question 4 reads, a farmer has 100 meters of fencing to form a rectangular paddock with a river on one side that does not require fencing as shown. So essentially this, and this, that adds up to 100 meters. And the first part of the question wants you to find a perimeter. So we know that perimeter must be equal to 100 meters. And if you were to write an expression for this, okay, so we know that this is x, this is also x. Let's say that is represented by the letter L for the length in this case. And we know the perimeter would therefore be, in this case, x plus L. But since we know that the perimeter is 100 meters, we can write it as 2x, because I just collected like terms, plus L is equal to 100. And because the question wants us to write an expression for the length, where you have to solve for L, we'll have to move the 2x to the other side. So therefore, L is therefore going to be 100 minus 2x. So that's the answer for part A. For part B reads, write an equation for the area of the paddock in terms of x, okay? So in this case over here, we know that the formula to calculate the area for a rectangle or square would be just simply length times width. So we just substitute what we know as our values for length and width. In this case over here, we know that the expression for length is 100 minus 2x. So we'll substitute that in, and I'll include brackets as well. 100 minus 2x, and the width is equal to x. So therefore, multiplying that by x. What I'm going to do now is I'm just going to expand it. So therefore, my answer will be 100x minus 2x squared. And that will be our answer for part B. Now, for part C, it asks you to find the suitable values of x, but I always recommend just skipping that question and always graph it first so that you can actually easily see what values are considered to be suitable in this case. So let's move to part D, where part D wants you to find, to sketch a graph for this particular equation over here. So in this case over here, because it's application type question, I'm only going to really draw just the positive a values and the positive x values, because you can't have a negative area. So I don't draw negative y values, and you can't really have a negative width as well. So that's why I don't include negative x values. So once I've done that, then what I'll do now is I'll have to solve for my x-intercepts. So in this case over here, if I was to solve for my x-intercepts, I could just use the null factor law from this equation to solve for it. So the null factor law, remember, states that we just essentially equate each of the factors to 0 and then solve for it. So in this case, if I do that, this is what my equation would look like, and x is equal to 0. So one of your x-intercepts is equal to 0, and the other one is therefore going to equal to 50 if you rearrange it. So you've got two x-intercepts, one is 0, one is 50. Notice over here, because your a value is a negative value, that means you're going to have an unhappy face parabola. So this is 0 over here. Let's say that this over here is 50. This over here is 0. And in this case over here, I could try to find out what the turning point is, but it's you can quite say that the turning point for this particular example is going to be when x is equal to 25, which is the distance that's halfway between 0 and 25. So my turning point is going to be somewhere around here, okay? And if I was to find out what was the y value for that corresponding x value, I just sub in x is equal to 25. Therefore, your y value, or your a value in this case, is going to be 100 bracket 25 minus 2 bracket 25 squared. What you're going to need to do now is put that into the calculator. So if you do that, 100 times 25 minus 2 bracket 25 whole squared, you're going to get an area that's equal to 1,250. And the unit of this is going to be meters squared. So in this case over here, if I was to add the coordinates, it will be 25,1250. And this is what my graph would now look like. Okay, so that's a pretty solid graph over here. Now, since we've finished answering part D, let's now go and answer part C. So in this particular case over here, the question wants you to find the suitable values of x. And in this case over here, the suitable values of x is going to be whenever you have an area that's essentially greater than 0. So therefore, in this case over here, your answer is going to be any values that's between 0 to 50 in this case, okay? So any value that's greater than 0, this will get you an area that's greater than, oh sorry, maybe I should reword that. In this particular case over here, it would make sense that if your width was 0, that would mean that you wouldn't really have a rectangle, you would just have a straight line. So that's what your fence would actually look like, or your paddock would look like, and that wouldn't make any sense at all. You need to have a rectangle of some sort. That's why the width needs to be greater than 1. So therefore you would have something like this at the very least. And similarly speaking, you can't have a x value, a width value of 50, because if you have a width of 50, then that's what your paddock would look like, and you don't have a fence that closes this off. So that's why any value between 0 and 50 would be the answer for part C. Now to answer part B, it's asking use the graph to determine the maximum paddock area that can be found, and that was when we found the maximum the y value of a turning point. So that's the answer for this one. That's going to be 1250 meters squared. And for part F, it's asking what will be the dimension of the paddock to achieve its maximum area. So in this case, we found out when the width was equal to 25. So in this case, if it's asking for the dimensions, you just have to write it in terms of length times width. So we know that your width is going to be equal to 25. So what is the length going to be in this case? To do that, all we need to do is substitute 25 back into this equation over here. So if you go that 25 times 2 is equal to 50, 100 minus 50 is equal to 50 over here. So therefore, this is going to be our answer. And you could also double check that by going 50 times 25, which also gives you 1,250. Let's now answer the next question. So the next question reads, a dolphin jumping out of the water follows a path described by h is equal to -½ x squared minus 10x plus 16, where h is the vertical height in meters and x meters is the horizontal distance traveled. How far horizontally does the dolphin travel out of the water? Okay, so for this particular question over here, what we need to do is we actually need to solve for the x-intercepts. The reason why we're trying to solve for the x-intercepts, because in this case, x represents the horizontal distance traveled. So we kind of need to know where did the dolphin start jumping from and where did it land, okay? So if you can kind of imagine in your head, the dolphin's like, let's say up here, it therefore travels and therefore it will land at a certain distance after from its initial point. So what we're going to therefore do is solve for the x-intercepts, and in this case over here, it's given to you in the standard formula, okay? And because it's given to you in the standard formula, you've got two options. You could either try to factorize it, or you could either use the quadratic formula, okay? And I always recommend, if you can, try to factorize beforehand if it works. And if it doesn't, then use the quadratic formula. But you do whatever method that is most suitable for you, whatever you feel comfortable with. So in this case over here, because we're trying to solve for the x-intercept, we're going to sub h is equal to 0. So therefore, our equation will look like -½ x squared minus 10x plus 16. And that is equal to 0, right? In this case over here, because I'm solving for it, I could get rid of this, I suppose, coefficient, you could say, this number, by just dividing both sides of the equation by -½ If I divide both sides by -½ 0 divided by -½ is equal to 0. So essentially, my equation would now look like x squared minus 10x plus 16 is equal to 0. And once it's like this, let me just see whether I can factorize it using the product sum method. So are there any two numbers multiplied together that gives you positive 16 but add up to -10? In this case over here, that would equal to -8 and -2. So therefore, it will be x minus 8, x minus 2. And you could also test this out by expanding it using the FOIL method. And hence, by using the null factor law, I can therefore say that my x-intercept is when x is equal to 8 or when x is equal to 2. So now that I've found out what my x-intercepts are, I can now answer part A. So if I was to roughly, again, draw what the graph is, this is just a rough sketch without finding all the information, it would look something similar to this, okay? I haven't found out what my turning point is, and it doesn't really matter for now. For part A, this is when x is equal to 2. That's when x is equal to 8. So what this is telling me is that the dolphin started from here. That's where it initially jumped. It moved up into the air because H represents the vertical height that it's jumped, and it landed back over here again. Okay, so that's when H is equal to 0. So that's when it's landed. So in total, the total horizontal distance that the dolphin has traveled in this case would therefore be 8 subtract 2, which is 6 meters. So for part A, your answer is going to be it has traveled 6 meters horizontally. For part B reads, does the dolphin ever reach a height of 5 meters above water level? Okay, and you need to give reasons. So essentially it's saying, is this vertical distance, is that going to, will the dolphin be able to reach a height of 5 meters or not? So essentially you will need to find out what your turning point is going to be. So in order to find your turning point, we'll just have to use the formula, the negative b on 2a. So that's one of the options. So for part B, you're going to have to use this formula over here, okay, to find out what your turning point is. So you have to refer back to the original equation to do so. But another quicker way to find out what is the x value of the turning point is just find the midway point between your two x-intercepts, okay? So in this case over here, we've already found the two x-intercepts. So I'm going to use the other method. So in this case, the distance, the halfway distance between 2 and 8 is equal to 5. So therefore, this particular point is going to be 5 comma something, okay? So since I know that my x value of the turning point is equal to 5, I'll just sub in x is equal to 5 to find the corresponding y value. So if I do this, h would therefore equal to negative half 5 squared minus 10 5 plus 16. I'll therefore simplify this, so it will be h is equal to negative 0.5 25 minus 50 plus 16, and therefore just put this all into the calculator. So if you do this, your h value should equal to 4.5 meters. Now that is the maximum height that the dolphin can therefore jump up in the air. So now let's answer part B. The question for part B says, does a dolphin ever reach a height of 5 meters? And in this case over here, your answer would be no, because the maximum height that the dolphin can reach is 4.5. So I'd say no, the maximum height that the dolphin can jump above water level is 4.5 meters. And that's how you'd answer your this particular question over here. Thank you for watching. Hopefully this helped you. If you need any more questions, feel free to email me. Have a great weekend. Bye.